Hi, welcome to reInvent, and thanks for taking the time to join this session. My name is Samantha Pham. I'm a Senior Product Manager at AWS, and I'm here to introduce our new Amazon EC2 G4ad instances for graphics-intensive applications. Taking a step back and looking at Amazon EC2's portfolio, we offer the broadest and deepest platform choice in the cloud. Our goal is to support every workload that works and runs on the cloud. To do so, we've innovated across our entire portfolio, from general purpose to compute optimized to storage optimized to hardware accelerated compute instances. In addition, we've also invested in our capabilities to improve what we're able to offer with these instances. We've added faster processors with a broader choice using our AWS Graviton 2, Intel CPUs, and AMD CPUs, offering up to 4.5 gigahertz of CPU frequency. We've also innovated in our hardware accelerated portfolio, where we've added our AWS Inferentia chips for ML inferencing. And we've added faster GPUs with the NVIDIA A100 GPUs that power our EC2 P4d instances. In addition, we've increased the networking bandwidth that we offer, where we can now offer up to 400 gigabits per second of networking bandwidth. With these innovations, we have now more than 400 instance types for virtually every workload and business need. Now, diving into graphics on AWS, we offer Amazon EC2 G4dn instances, which are the lowest cost instances in the cloud for graphics. They're powered by NVIDIA T4 GPUs and come with NVIDIA grid licenses at no additional cost. We also offer our EC2 G3 instances, which are powered by NVIDIA M60 GPUs, which also come with the NVIDIA grid licenses at no additional cost. For customers that want a fully managed service for their graphics use cases, we offer Amazon AppStream and Amazon Workspaces. Both of these services offer the ability for customers to stream applications and provision desktops from the cloud. They both offer a wide range of GPUs to accommodate your graphics needs from low-end to high-end using NVIDIA and AMD GPUs. We've had feedback from customers that even with all of these options, they need higher performing GPUs for their graphics use cases at a lower cost. And so we've introduced our Amazon EC2 G4ad instances, which come with AMD Radeon Pro V520 GPUs and AMD second generation EPYC processors to deliver higher graphics performance at a lower cost. This combination of AMD GPUs and CPUs offer up to 45% better price performance than our currently lower cost G4dn instances. Taking a look at the GPUs that power these G4ad instances, the AMD Radeon Pro V520 GPUs come with 36 compute units, 8 gigabytes of high bandwidth memory, and are built using AMD's new RDNA architecture, which is hyper efficient with low latency and high CPU to GPU bandwidth. They are designed to render your graphics with high quality at high speeds, and they have a peak engine clock of 1600 megahertz. These instances are built to be optimized for graphics use cases like remote workstations, for graphics-intensive workloads like game development, creating animation and visual effects, and editing live-action videos. The instances are also great for game streaming to allow you to stream premium games and experiences to your customers using any device at any location at any time. The instances are also great for graphics rendering to render photorealistic 2D and 3D images using GPUs. One customer that's really excited about these new G4ad instances is Ubitus. Ubitus is a cloud gaming technology leader. They build platforms to provide AAA gaming experiences to customers on any device, including smartphones, tablets, gaming consoles, smart TVs, and computers, as long as they're connected to a broadband network. Wesley Kuo, the CEO of Ubitus, said, "We use AWS to partner with 505 Games to bring Control Ultimate Edition to a highly popular portable gaming device. With the new EC2 G4ad instances, we have a lower cost structure, which will enable us to bring more games like Control Ultimate Edition to mobile users globally." Now that we've introduced the instances and what they're used for, let's dive into their performance. To talk about performance, we're going to compare the G4ad instances to our G4dn instances. The instance sizes we selected is the 4x large because they're equally spec'd, and you'll see the G4ad instances represented by the orange bars and G4dn instances represented by the pink bars. The first benchmark that we'll look at to compare performance is the GFXBench Aztec Ruins benchmark. This benchmark renders a scene with demanding game-like content using Vulkan API as the underlying API. It measures frames per second rendered by the system as the scene is playing. There are two modes that the benchmark runs in. The first is the normal tier mode, which runs at an 1080p resolution. Using that mode, we've seen that G4ad offers 39% better performance compared to G4dn. With the high tier mode that runs at a higher resolution of 1440p, with more effects and textures to increase the complexity of the graphics, we see that the G4ad instances outperform the G4dn instances by 36%. The second benchmark we'll look at is SPECviewperf 13. This is an industry standard benchmark to measure graphics performance based on common professional applications like Autodesk Maya, PTC Creo, Dassault Systems CATIA, and Siemens NX, and medical workloads. This benchmark works by measuring the frame rate while rendering various scenes across different modes to create a weighted geometric mean to calculate the composite score, which is displayed in this graph. As you can see with Autodesk Maya, which is used to create assets for 3D applications like video games, animated films, TV series, and visual effects, G4ad performed 33% better than G4dn. PTC Creo, which is a computer-aided design app to support product design for discrete manufacturers, saw a 35% improvement in performance using G4ad compared to G4dn. Dassault Systems CATIA, which is a computer-aided design app for product development for things from conceptualization, design and engineering to manufacturing, offers a 23% better performance for G4ad versus G4dn. The benchmark also uses a range of view sets to model real-world medical applications by using raycasting for volume visualization. And using those view sets, we see a 47% better performance using G4ad compared to G4dn. And lastly, looking at Siemens NX, a high-end computer-aided design app for parametric solid modeling, engineering analysis, and manufacturing, we saw a 638% improvement on performance for G4ad compared to G4dn. The last benchmark we'll look at is superposition. Superposition stress tests the GPU by rendering a scene with top-notch visuals using DirectX as the underlying API. Like Aztec Ruins benchmark, it measures the frames per second rendered by the system as the scene is playing. Using a 1080p resolution to run the benchmark, we saw a 20% improvement on performance for G4ad compared to G4dn. With that, let's talk about the instance sizes that we'll offer with G4ad. G4ad will come in 3 instance sizes, ranging from 1 GPU to 4 GPUs. The smallest instance size we'll offer is the G4ad.4x large, which comes with 1 GPU, 16 vCPUs, and 64 gigabytes of memory. You'll see a consistent ratio of 1:4 vCPUs to memory across the board as you move up on instance sizes. The largest instance size we offer is the 16x large, which comes with 4 GPUs, 64 vCPUs, 256 gigabytes of memory, and 2.4 terabytes of local storage. They also offer 25 gigabits per second of network bandwidth and 6 gigabits per second of Amazon EBS bandwidth. All of these instances are powered with AMD second generation EPYC processors, which offer clock frequencies up to 3.3 gigahertz. Now we want to share a demo about how these instances can be used in real life. Kevin Ashman, our senior partner solutions architect in our AWS Game Tech org, has created a demo using G4ad instances for content creation workstations. In his demo, you'll see that he used Teradici as the remote display protocol, but customers can also use NICE DCV as an alternative as a high-performance remote display protocol to securely deliver remote desktops and application streaming from any cloud or data center to any device. NICE DCV comes at no additional cost with your EC2 instances. And so now we'll get into that demo.
All right, let's take a look at what we can do with these AMD instances. One of the things we wanted to showcase was being able to get into one of these instances as a virtual workstation. What you can find up on GitHub in our AWS samples is our content creation workstation, which lets you do just that. The content creation workstation uses CloudFormation and deploys one of these AMD G4 instances into your AWS account, where you can access and then get into that instance and do a whole ton of great things. In my situation, I'm a partner solutions architect with the AWS Game Tech team. And one of the things that our developers do is use game engines inside of these virtual workstations. So we'll take a look at that, but I'll show you what you need to do to get started. First, you can synchronize this GitHub repository. There's various parameters that you can review, and then you launch them from the command line parameter. Parameters include which instance type you want, but really a lot of the defaults work really well. You can deploy them into your own VPC, or you can create a new one. We're not going to step through that just for the sake of time, but let's go and take a look and jump into one of those instances. So here we are in this instance, and you can see that it's powered by the AMD Radeon Pro V520 GPU with the EPYC processors available to you. One thing to note about the content creation workstation is it utilizes a technology called Teradici, which is an AWS partner that offers a high resolution, low latency, really good tool for virtual workstations. And what we're looking at right here is a statistics viewer that will let us know how it's working. Right now you can see the frames per second that we're getting. It's let's take a look. It's at around 10, 15, 12 frames a second. And that's low because we're not doing much. But as you can see, as soon as I started interacting with the EC2 instances, the frames go up. And you would want that just to save bandwidth. Now, once you load up one of these content creation workstations, you can install any software you'd like. For me, what I wanted to showcase was Unreal Engine. Unreal Engine is a powerful game engine tool set, and it really can leverage the GPU and the CPU power that these instances offer. I'm in what's called their shooter game sample, and I'm recording this video from the instance remotely. And on the instance, we're getting upwards of above 100 frames per second. And then now you can see as we were in that editor, the frame rate was high, and now it's dropping back down, of course, to save frame rates. And as we flick around inside this viewer, it basically on demand gives you the frame rates that you're going to need. And now it goes down to a baseline to help reduce the bandwidth that's consumed. So the content creation workstation really allows you to get in and utilize the power of these AMD G4 instance types and do a lot of great things. This example showcases the ability to use Unreal Engine. Once you have Unreal Engine installed in one of these AMD G4 instances, you can utilize a lot of other AWS resources because, of course, all the processing work is happening remotely. So that's one of the use cases that we wanted to cover. Another is the ability to use these instances to deploy content to viewers. So there's another sample up on AWS samples that allows you to deploy Unreal Engine content via pixel streaming. And what this solution does is it takes an Unreal Engine project zipped up in S3 and places that on one of these AMD G4 instances, and then lets you simply connect to it via a modern web browser. So it's a very minimal amount of steps you need to take to deploy this Unreal content into EC2 and make it available globally. So it utilizes CloudFormation. So we can go into a stack. I've already jumped into a stack here where I've pointed at it just to show you a bit of the parameters. It doesn't take very many. You name it, and then it runs on Windows Server. You set a password, or there's a default. You can use various instance types, including the G4DN or the G4AD. And then you set a different key pair. You set your pixel streaming location as far as the bootstrap, which is just some configuration scripts that get executed. And then finally that zip file, right? That pixel streaming zip file that is the project that you've built. And once you add that, you hit next and you go through the build, you end up with a URL as an output. And in this case, it's just pointing to the EC2, and we can click to that instance, and then we can start to engage with that content. And again, this is running on the EC2 instance itself, streaming those pixels to whatever viewer is connecting to it via any modern web browser. So these are two different samples that we wanted to showcase you. This pixel streaming sample is out there available for you, as well as the content creation workstation for you to utilize these new AMD G4 instances. That's it for me. Thanks.
I hope you enjoyed that demo. And if you'd like to get started on trying these instances out yourself, they're going to be available starting in US East 1, North Virginia, US West 2, Oregon, and EU West 1, Ireland. And we'll add more regions coming soon. These instances are supported on Windows Server 2019 and 2016, as well as Amazon Linux 2, Ubuntu, and CentOS. The instances come with AMD Radeon Pro software graphics drivers at no additional cost, which are AMD's powerful and reliable professional-grade graphics software designed to unleash your creativity. The graphics drivers from AMD support DirectX 12, 11, 10, 9, and Vulkan and OpenGL as the graphics APIs. Using these graphics drivers, you can get up to 2 4K monitors per GPU with nice DCV and Teradici. If you'd like to learn more about these instances and how to get the drivers and use them on the instances, please visit our G4 page. And lastly, let's talk about pricing. With G4AD, the lowest cost instance size is the 4x large. On demand, using Linux, they cost only 86.7 cents per hour, which is more than 25% lower than the equally sized G4DN instances. Because we know Windows is really crucial for our graphics customers, we also want to share that the Windows pricing for on-demand instances is $1.60.3 per hour, which is 15% lower than our G4DN instances. The instances are all also available with 1-year and 3-year terms for savings plans and reserved instances, and also available on spot and dedicated hosts. That's it for pricing. Thank you for joining this session, and I hope you enjoy the rest of reInvent.